Hello everyone, welcome to this video. In this video, we are going to learn about support vector regression using OpenMathAI. So, let's get started. What is support vector regression? Support vector regression is a supervised machine learning algorithm used for regression problems. It is based on the support vector machine concept and is used to predict continuous numerical values. Unlike linear regression, which mainly learns a straight-line relationship, SVR uses kernel functions such as the RBF kernel to learn complex nonlinear patterns. SVR works by creating a prediction curve that keeps most training data points within a specified error margin called epsilon, instead of trying to pass exactly through every data point. It focuses on finding a smooth prediction function with minimum error. The regularization parameter controls the balance between model simplicity and prediction accuracy. During prediction, the new input is compared with important training samples called support vectors. The selected kernel function measures the similarity between the new input and these support vectors. Based on this similarity, SVR calculates a predicted output value. Imagine we want to predict the energy consumption of a building using the outside temperature. Energy consumption does not always change in a straight line. It may increase during very cold or very hot conditions because heating and cooling systems consume more power. SVR can learn this smooth nonlinear relationship and predict energy consumption for new temperature values. We will use a temperature-based energy consumption dataset for the SVR model. This dataset contains 150 data samples. The input feature is temperature in degrees Celsius, and the target output is energy, consumption in kilowatt-hours. During training, SVR learns a nonlinear relationship between temperature and energy consumption. Once the model is trained, it can predict the expected energy consumption for new temperature values that were not included in the training dataset. So, let's get started. OpenMathAI. In this demonstration, we use the energy consumption using SVR model. Click Create New Project. Enter the project name as Energy Prediction. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There is also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There is one more feature, Signal Diagnostics. There is 3 columns. First one is column, it tells which features are in the dataset like inputs and outputs name. Second one is VIF, it tells how much correlation of the features. Third column is status, if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the SVR model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95, accuracy almost equal to 95%. Click Fit to Window. You will see three types. Fit to Window, comfortable, compact. Then the clear history. If you click that, it will clear the history before its trained model. Another is deselect and select all trained models for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format: ANSI, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these formats and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.